Illustrative Math, Unit 3, Lesson 14 is called More Arithmetic with Complex Numbers. So our goal today is I can do arithmetic with complex numbers. So, when I say arithmetic, okay, we're thinking, addition, subtraction, multiplication, division. Obviously, there's other things, squaring, square roots, but these are the four that we're going to focus on. Okay, so obviously with real numbers, you learn how to do that in fourth grade. Addition with real numbers, subtraction with real numbers, multiplication with real numbers, division. Okay, we know how to do that, but can we do arithmetic? And actually, honestly, we're not going to really do division today. We're going to focus on some of the other things. All right, so which one doesn't belong? Pause the video, try to come up with a reason. All right. So A, you could say, because I squared is equal to -1, you could say this is the only one that has a real number only when you simplify it. Let's see, you could say it's the only one with a negative value. It doesn't have a 1 plus I, a 1 minus I, it's just a I squared. All right, go to B. This is the only one that involves the sum of two complex numbers. C, you could say it's the only one with a complex number squared. You could say D, if I multiply these, I'm going to get 1 negative I negative I squared, which this is going to be -1. So actually I was wrong. This one's just a real number as well. This ends up being 2. This ends up being -1. So these ones are real numbers. We haven't really learned how to add these yet. We're going to do that today, but basically think of it like a 1 in front of each parenthesis. If I distribute the 1, I end up getting 2 there. If I come over here, this is really 1 plus I times 1 plus I. So if I multiply the 1s, 1 times I, 1 times I, then I times I is I squared, which would be 1 plus I minus 1. This ends up being 2I. So, actually, this is the only one with an I, so that would be a good reason that C doesn't belong. When you simplify it all out, it's the only one that has the imaginary part. A, you could say, is the only one that ends up being a negative number. Bunch of different reasons. All right. So a couple things. Remember, what is I? I comes from the square root of -1, and if you remember, I squared is equal to -1. Why is I squared equal to -1? Well, if I square both sides here, I squared, the square gets rid of the radical. That's how we end up to that. So write each power of I in the form a plus bi, where a and b are real numbers. If a or b is 0, you can ignore that part of the number. For example, 0 plus 3i can simply be expressed as 3i. All right, so the first thing, anything to the 0 is 1. So that's it. I to the first is going to be just I. I squared is -1. All right, those three are pretty simple. Now here's the key. The trick is to rewrite them in powers of I and I squared. So why don't I see how many I squareds I can get? I can get 1I squared and then 1I. If I add my powers here, because that's a 1, would be 2 plus 1 would be 3. So now I can say, oh, okay, it's -1 times I, which is -I. I to the fourth. How many I squareds can you get here? I can get 2 of them. Every time you have I squared, it's -1. So what's -1 times -1? +1. So this is important to understand. I to the fourth is 1. We're going to come back to that here on this one. If I rewrite this as I squared times I squared times I, -1 times -1 times I, -1 times -1 is 1. So it's 1I. Now, the easier way to do this is if you know here, so put this somewhere in your notes, in your memory bank, I to the fourth is equal to 1. Okay, and we just showed it right here because I squared times I squared is the same as I to the fourth, and we know I squared is -1, so -1 times -1 gives me 1. If I wanted to for this, and I guess I'll do it over here on this side, if I wanted to write the I to the fifth as I to the fourth times I, and again, why can I do that? Because when I add those powers, you know your algebra rules. If I have, x to the m times x to the n, it's x to the m plus n. You add those, you get the 5. We know that I to the fourth is 1. 1 times I gets me I. And so now that I know that, any power greater than 5, maybe I should rewrite it as many powers of 4 as I can get. So that'd be I to the fourth times I squared. I to the fourth is 1. I squared is -1. I get 1 times -1 is -1. I to the seventh. I to the fourth. And then I have 3 i's left, so I'll go with 2 times 1 because I don't know what I cubed is, but I know what all 3 of these are. I to the fourth is 1. I squared is -1. I is I, so it's going to be -I. And I to the eighth. I to the fourth, I to the fourth. I to the fourth is 1. 1 times 1 is 1. All right, now if you're like, well, I'm not sure why you're writing it powers of 4, you can write them as powers of 2. And it's -1 times -1 times -1 times -1. 4 negative signs, you get the 1. Same thing. All right, so what you're starting to see is when you start writing it as powers of 4, what you're really looking for is the remainder, basically. So I to the 100th. If I take I to the fourth to the 25th, multiply your powers, that would give me 100. So this is equivalent to that. So really, I to the fourth is 1. 1 to the 25th is just 1. Okay, now if you wanted to, you could say I to the fourth. You could do it, until you have them add up to 100, but that's a little bit not really practical here. So let's see here if I could do this one, kind of the same idea. So what I'm going to do is I'm going to take the 138 and I'm going to see how many times 4 goes into 138. Goes in 34 full times. So I'm going to say I to the fourth to the 34th, because if I multiply those, 4 times 34 gives me 136. So remember, I have I to the 138, so I need 2 more. So I'm going to say times I squared. Okay. So this is 1 to the 34th. This is -1. So this is 1 times -1. I get -1. Okay, so the key on any power of I is basically divide it by 4 and write the remainder as a power of I. Okay, so let's do one more here. Let me just make one up here for number 4. So let's say I have I to the 21st. So 4 goes into 21 4 whole times. So I take I to the 5 whole times. I to the fourth to the 5th. That would get me my 20. I need one more to make this equal 21. Remember, I to the fourth is 1. 1 to the fifth times I. This is 1 to the fifth power is 1. 1 times I. It's just I. Okay. All right, for each row, your partner and you will rewrite an expression so that it has the form A plus BI, where A and B are real numbers. You and your partner should get the same answer. If you disagree, work to reach agreement. All right. So this is just addition. So 7 plus 3 would give me 10. 9i minus 4i is, positive 5i. Come over here, I'm going to get 5i if I distribute, minus 10i squared. Remember, I squared is negative 1. So this is negative 10 times negative 1. So that's positive 10 plus 5i. All right, we're good on that. Distribute, we're going to get 6i plus 8i squared. Remember, I squared is negative 1. So this is negative 1 times 8. So I get negative 8 plus 6i. I always like to put the real number in front because it's a plus bi. You got the real part is the a. The bi is the imaginary. So this is 1 plus 2i. Distribute the negative 1, and I'm going to combine the real numbers, negative 9 plus 1. 2i plus 4i is 6i. Looks like it works. Over here, now I got to multiply this. So, you could do the FOIL method, or if you want to draw a box, draw a box. I get 16 plus 12i minus 12i minus 9i squared. So these add up to 0. This is negative 9 times negative 1. So that's positive 9 plus 16 would give me 25. Over here, I get 5 plus I plus 20 minus I. Those add up to 0. And I get 25. So here, this has got to be 2 to the fourth times I to the fourth. 2 to the fourth is 16. I to the fourth we just learned is 1, so that's 16. Come over here, whoops. 3 times 3 is 9. This gets a little tricky, but it's going to be negative 3i on the outside times the square root of 7. This is going to be a positive 3i on the outside times the square root of 7. And then over here, we're going to get negative I squared. And then radical 7 times radical 7 is just 7. So these cancel. So this is negative 1 times 7. So that's positive 7 plus 9 gives me 16. Awesome, it worked. Okay, over here, this is going to be 1 plus I radical 5. I got to distribute this negative sign here, so that's plus 7 plus I radical 5. So that's going to be 8 plus 2I radical 5. These are like terms. So you just add really it's a 1i and a 1i. So I add them to get the 2i. And you keep the radical the same. All right, here I got to distribute. This is going to be positive 2i radical 5. And then this is going to be negative 8 I squared. Remember, I squared is negative 1, so it's negative 8 times negative 1. So this becomes a positive 8. And then I got I forgot the coefficient. Plus 2i radical 5, which, awesome, they check out. All right, a little bit harder over here. We're going to multiply the coefficients. So I'm going to get, let's see here, 1/2 times 1/3 times 3/4. I don't have to distribute or anything because there's no plus signs. So it's going to be 1/8 I cubed. Probably need to get it in a complex number form. So let's do this. Let's make it I squared times I. I squared is -1. So I get -1/8 I. Over here, I get 1/2 cubed, I cubed. This is going to be 1/8. And I guess I kind of already did it over here. It's going to be -1 times I. So I'm just going to make it -1 times I. There we go. They match up. All right. So how is arithmetic with complex numbers the same as with real numbers? How is it different? How is it the same? I would say if you, let me make this a little smaller. Say same would be if you do arithmetic on a complex number, you will get a complex number. Okay, because and you might say, well, that's not true. You did some earlier here where we got to a power and we only got a real number, but you can always put plus 0i. Okay, so you can always add a 0i to make it complex. What else is what's different? You need to know what I squared is. Whoops. All right, because if you don't know what I squared is, you kind of get to a dead end. Because you can't have powers of I greater than 1. Okay. What else? It is harder to do arithmetic with complex numbers. Okay, you can't just do it in your head. What are some things about complex numbers or radicals you didn't understand very well first, but now you feel you understand much better? Obviously, this answer can vary. I would say powers of I can always be broken down into smaller powers, such as I squared or I to the first or I to the fourth. Those are all very helpful. All right, last thing here. I can do arithmetic with complex numbers, pretty much addition, subtraction, multiplying, dividing, and now powers. All right, so suppose C equals -11 plus 3i. What two non-zero complex numbers could have been added to make C? Okay, so really, you need any two numbers that let's see here, we got a complex number. So you got your A, your BI, and then you got your A and your BI. And we want those to equal -11 plus 3i. So really any numbers that add up to -11. So like maybe I had like -12 plus 1. Those two added up will give me the -11. Maybe this was 1i plus 2i. Add those together, we get the 3i. Okay, a bunch of different answers here. You could have, I don't know, let's say -6 plus -5. Let's say 4i, -1i. That'll work as well because -6 minus 5 is -11. 4i plus -i is 3i. All right, I to the ninth. So how many smaller powers? Usually 4 would be the best to do it. Every I to the fourth is equal to 1, so that's 1 times I. There we go. All right, hope you enjoyed this video, and thanks for watching.